Okay. So these are all the main topics that we'll be covering. Basically, we'll be starting with the introduction part, and where we'll be looking at different topics that we'll be covering over here. So these are the main topics. Like you see here, these are the main topics that we'll be covering. Like we'll be starting with types of data, and then we'll be basically we'll be starting with population and sample. Basically, what is a population, because that is very important topic, population and sample. And then we'll be moving towards types of data and levels of measurement. And then we'll be looking into categorical and numerical data differences, right? How to plot them on the graphs, right? How to visualize them. And we'll be looking at measures of central tendency, where we'll be learning basic definitions of them, and we'll be getting some deep insights on these three things, like these three measures, and you'll be solving exercises related to measures of central tendency. And it would be the same with measures of variability, where you'll be learning variance in detail, right? And the related topics like coefficient of variance, and then you'll be learning standard deviation, and then you'll be touching upon covariance and correlation, right? All these things will be touching in measures of variability. That is the second topic. And then you'll be learning about the skewness also, which is not shown over here. And then you'll be learning central limit theorem, where we are going to start upon our distributions basically. So we'll be learning what a distribution is, what kinds of distributions are there, and why normal distribution is very important, and then how we can convert any distribution to a normal distribution using central limit theorem, right? And then we'll be looking at student state distribution, right? Along with that normal distribution, and why it is important for us. And then we'll be going to confidence interval calculations. And this is a very important tool for a data scientist, especially data scientists and data analysts, right? Whoever is working in data science background, basically. It is very important for them to understand this tool, confidence interval. And we'll be solving some practical examples on this one also, so that we'll be getting a good understanding on confidence intervals calculations. And then we'll be moving ahead to hypothesis testing. So this is also a very important tool, hypothesis testing, where you'll be formulating your business problems into hypothesis, and will be testing them. We'll be testing them for enough evidence, whether whatever the condition for which we are testing, we are going to test the hypothesis on a sample, and we are going to infer the same thing to the population. That's what we are going to look at. So that's what is all about hypothesis testing. But don't worry if you're not understanding about these topics as of now when I'm telling you. Don't worry, don't be so much bothered about them. We'll be taking in detail all of them, right? And then we'll be finally looking at a regression analysis, where we'll be looking at different terms that we're going to use, like R square, adjusted R square, right? F stats. What are each and everything? Like what is the definition of each and every term, and how they are formulated, and how we have to use them, and what is their significance. So you'll be learning more statistics in a more more sensible way, or more meaningful way, so that you can use them, you can apply them on your data or in your day-to-day life. Even in your day-to-day life, you will be able to generalize the things, right, with these tools that you're going to learn over here. Fine. So here there are a few important things that I would like to point out before starting this course. So here, what I suggest is, each one of you, today we have very good strength. We have around 37 members. As I heard that in classroom we have 15 members, and online we have 25 members present over here. Of course, excluding me and excluding, let us say, organizers, let us say 2 or 3 people, let us say 23 here and 15 over there. If you see, we are at least 35 people minimum, So this is very good strength. I wish that, and I recommend and I advise and I request each one of you, please don't miss any lecture, because our data science, especially the data science, is standing basically on the basement of statistics. Without statistics and without probability, there is nothing in data science. Of course, there are some tools, I understand. Python, there is a Python, Tableau, Power BI. Of course, they can be learned within weeks' times. But if you don't know base, if you don't know technically, if you are not able to understand the problems, if you're not able to do them, then of course you'll be again coming back and relying on your theory subjects. So it is better that now you are starting with theory. So try to concentrate on that, and once for all, it will be done. So you don't have to learn theory again and again. Of course, tools will be changing. Today we have Tableau. Today we have Power BI. Tomorrow some other tool is going to come. But they will be covering the same topics. They'll be using the same things again. But the base will never change. So that is the reason I'm telling you all. So don't miss all the topic. I mean, those miss any of these topics that we are going to discuss in statistics, right? And then I'm going to give some extra resources like course notes, exercises files, and PDF material, handy notebook files. So you keep them with you, and I request you to practice. I mean, you need to practice. So here we are going to use Excel as our mode to learn statistics basically. And we are going to cover those topics of statistics which are very essential for data science as of now to start with, right? And then we'll, as and when we get time in the future, we'll be adding the topics more and more, and we'll be making them more detailed. Don't worry, right? So that's what I wanted to say. So are we all set to go? So I'm starting with the main core topic of the statistics. So before starting on with the numbers in statistics, it is very important to understand what a population is and what a sample is, right? What a sample is and what a population is. So hope you have at least you might have studied in your high schools. What do you mean by a population? Because I hope, is there anyone who doesn't have any touch on the statistics in this class? Please let me know in the chat box, please. Is there anyone in this class who doesn't know even base of statistics, who have never touched upon statistics in their lives till today? Is there anyone? If there is anyone, please type N in the chat box. Please type N in the chat box. Is there anyone? Is there anyone? No. So each one of you studied statistics in your high schools, right? Or before high schools? Good. So with that inspiration, I'm going to ask you a question. So if you remember, what do you mean by a population and what do you mean by a sample? Anybody remembers basic definitions, or at least if they can comment on this definitions? Pose your views at least. What do you mean by population and what do you mean by a sample? If you really don't know, that's fine, but are you really kidding me? Nobody knows what a population and what a sample is. Just you can express your views at least.
Population is the entire range, and sample would be just a part of that population. which we select.
Yeah, absolutely. Thanks, Nikhil. Thank you very much for the reply. Yeah, Paul is telling total number of students is called population, and sample would be random chosen items collection of sample. Yeah, of course, Valu, to some extent, yeah. What you are telling is that's fine, but I was asking basic definition. Yeah, collection of sample. No, Vamshi, you are also not to the mark.
Sample
Okay.
is nothing but number of observations or taken from a population.
Not bad. I need a general term. What exactly does it, like population mean?
Group of items,
Uh,
population, and sample is taken random sampling like
okay.
that, something.
Okay,
Yes.
no problem. So why are we doing this statistics course? What is the main intention of this course? So the basic intention of learning statistics itself because we have huge data, from there the story is starting because we have data. Story starts from there again. Because we have data, right? That too huge amounts of data. Data is going in exponentially, like it is increasing in the exponential way. I think everybody knows what an exponential word term exponential means. It is increasing like drastically. The speed is very high. At that speed, it is increasing. So we are with huge amounts of data. So when we have huge amounts of data, what we are going to do? In statistics, statistics is the basic study of data. That is the reason statistics has come into the play. Of course, we have huge data. What we have to do with that data? Of course, I have data. What I have to do with that data? I should have some tool, right, to apply on it. So statistics is providing some tools to apply on the data. So let us suppose we didn't have data. So there was no need of statistics at all, right? Statistics is nothing but using the data, right? So you're applying the tools of statistics on data. So from there, the requirement starts. So with that, what we say, population, whenever we want to do certain analysis, whenever we want to do certain analysis, what we do? We need some data. So it is nothing but the collection of items of interest or study. Like it is the collection of items of interest of our study. So whatever the analysis or whatever the problem that we want to analyze, for that problem with the existing data, whatever the data that we are going to collect for analyzing the data, relevant data. I mean to say we have huge amounts of data, whatever the relevant data that we are going to collect for doing our analysis or to resolve our business problem is called as population. It is nothing but a population, right? So I hope everybody is clear with the definition of population now. So it is collection of all relevant items of our interest for our study. So if you don't have your study or analysis, then you don't have to do all this circus, right? You have data and you have problem. That is the reason you are collecting the data for your study. So when there is no problem, there is no necessity of the data, or there is no necessity of the collection of items on which you want to study. Correct or wrong? So that is what is population. So population is nothing but collection of all the items of interest to our study, and it is represented by capital N. Even now, if you are not clear on this one, don't worry, we'll go ahead and look at an example, then we'll be crystal clear on what a population is and what a sample is, right? So this is always represented with capital N. You remember these things, right? And we have certain formula for population. We have certain formulae for population as well as for samples. So we have not yet dealt with samples anyway. So whatever the numbers that we are going to get out of these formulae, they are called as parameters. What are they called as? They are called as parameters. Please remember this term, parameters, and then we'll go to see what a sample is. What do you mean by a sample? What is the English definition of sample? What exactly, what do you understand by a sample? Have you ever come across, like in your life, what a sample is? Have you ever come across this term sample? No one has come across sample.
Yeah.
Yes, sir. Yeah. Sample is like
Did you have heard what a sample?
format, a set format, an example.
No. Real life. In real life, where you have seen a sample.
While checking the rice is cooked or
Blood sample like that. Yeah.
Vamshi is telling blood sample.
Me. It's me, sir.
In your real life, have you ever given blood sample? Everybody might have given blood samples, right? In the laboratory. No? Each and every one of you have given, might have given blood samples. Most of you, I think. Right or wrong?
Yeah.
Yes, sir.
So blood sample, what does it mean? Sample is nothing but complete whatever the blood you have in your body, it is the population. And for the study, you are facing some problem. You have got some disorder. To study that problem, they want to study on the sample of your blood, not completely. They are going to take out complete blood out of your body, and they are going to, if they do that, you are going to expire. So for that, what they are going to do? They are going to take a sample, only a sample of the blood, and they are going to test on that. And they are going to say that, okay, so with this we are going to understand, and these are the problems. This is the this is the what do you say, hemoglobin count, white blood cells count, red blood cells count, everything. They are going to come up with certain numbers, right? And they are going to generalize those numbers to the complete population of your blood in your body, right or wrong?
Yeah.
So that's
Yes,
what. So that's what it is. That's what it is. So sample and population. So complete. It is impossible. We'll see how it is. So what is a sample? Sample is nothing but a subset of the population. Sample is a subset of a population. So it is always denoted by small n. It is denoted by small n. And whatever the numbers that you're going to get out of the formula of sample, they're called as statistics. They're called as statistics. So these are the formal definitions of population and sample, right? A population is collection of all items of interest to a study and is usually denoted by uppercase N. The numbers we have obtained when using a population are called as parameters. A sample is a subset of population and is usually denoted by lowercase n, and the numbers we have obtained while working with samples are called as statistics, right? And now you know why the field we are studying is called statistics. Now you understand I hope every one of you understands why this field is called as statistics. Why is it called as statistics? Statistics always deals with, come on, statistics always, pardon?
Samples.
Yeah, statistics always deals with samples, right? That is the reason we're telling it as statistics. Here it is the reason, that is the reason it is called as statistics. Correct, no? Right. Now you have seen blood sample example, what to understand, to get a basic understanding on what population and what a sample is, right? Now we'll look at this example. This example is based on the population, right? So if you see here, let's say we want to make a survey of the job prospects of the students studying in New York University, right? This is what is my problem statement, or this is what is my area of study or interest that I want to do, right? The survey which I want to do for the job prospects of the students studying in New York University. So the question immediately rises over here is, what is the population for this survey? What is the population?
Students.
Pardon?
Students is the population here.
Students is population, but which students?
Prospect
You mean to
students.
say students means you mean to say students starting from 0 class to university level, or the children who are not studying, or who are, what is population exactly over here?
Students who are looking for a job.
Students who are looking for job. See the problem statement, I mean the study that we want to do.
Students
Job
studying in
prospects.
New York City.
Students studying in
New York City
university.
is the population.
I mean, who the students studying in New York University. I want to know the job prospects of the students who are studying, and I mean who are studying in New York University. I want to know basically the job prospects of the students of New York University. That is the problem statement, right? So what will be my population?
Job seekers.
That
So we have seen this example before also. So it takes into consideration everyone, the passed out students, the distance who are studying distance education,
correct.
and the college students.
Exactly. So here Vamshi is telling, I'm sorry, I'm not able to see these messages. Okay, entire students in the university. Entire students who are studying in the university, Balu? Purnima is telling distance education part-time job like that, sir. Okay, students who have job features in New York City and passed out students, right? Previous student, right?
Yes,
Right,
sir,
Balu?
at high school, but who are not enrolled at NYU,
Yeah, yeah. Of course, yeah. See, if you see here, when
abroad,
I'm telling
or
prospects,
exchange.
yeah, of course, exactly. So when I'm saying job prospects, the term job prospects itself applies to the students who are already from the beginning of the university, when the university was started, to the present time, right? Till now, whoever has studied in that university, those students will be the population. Am I right or wrong? If I do a study on that population, that should be the basic population. I don't know what are the categories that are going to come. Of course, I'm going to name a few, but you cannot just say that I can simply walk into the university and find every student over there and I'll just do a survey over there. That's not fair, right, for this survey, right? So I will name some students. These are only a part of students. See, there are some students who are sitting at home. There are some students who are on exchange, let us say. There are some students who are studying in France and they want to study in, let us say, New York. And there are some students who are in New York University and they want to study in Paris. Likewise, they have come to some other university and they have come on exchange. Many things they happen like that. I don't know whether you are aware of this topic or whether you are aware of this exchange programs or not. But they do. It is very frequently these things happen in foreign universities. People studying in Sweden, those people take some exchange or exchange program for 5 or 6 months and they'll go to Australia. Swedish people, they like more to study more in Australia. Likewise, the students, they have preferences. They have their own preferences. So they will go on exchange. And there are some people who are abroad. There are some students who are abroad, right? Of course, they have studied in New York, but they're doing jobs in Singapore. They're doing jobs in Malaysia. They're doing jobs in, let us say, Australia, New Zealand, somewhere like that. And there are some distance education students who are doing distance education. There are some students who are doing part-time. They're studying only on part-time basis. And there are some students who are at high school, but they have enrolled to New York University, but they have not yet joined. So these are only a few lists which I'm telling you, but there are, when I'm telling the university was started at some point of time and one batch was completed. And from there, I have to consider everyone, right? Am I right or wrong? If I want to study the job prospect, that would be the population. If I ask a question, what would be the population? That would be the population. Basically, when the university was started, on the day it was started, from there, and if I consider till today, if I have to do a detailed analysis, that would be a detailed analysis. And if I want to do a detailed analysis, I want to consider the population, that would be the population. Of course. Am I right or wrong? Is there anybody who wants to oppose my point? Is there anyone? You agree, right, with my point? See, this is generalized thing, right? But if you see, I cannot go on search, right? University may have started in some 19th century, and today it is 2021. I have to go and collect the data of, let us say, how many people, how many students, I don't know, how many years it is. More than 100 and let us say 120 years of the data I need to collect. Or is it easy to collect the data? Nearly impossible. No, it is not nearly, it is impossible at all, right? I cannot collect complete data. And first of all, university should support. And I don't know whether university is maintaining all the data or not from the beginning. And many people have died even today. They are not existing at all. So how do you do that? So that is the reason we are telling that. That is the reason we are telling that. So the list seems to be exhaustive, but the list misses someone. It is missing someone. It is missing someone. Someone has died and gone away. We cannot go and ask them. They are sitting somewhere in heaven or hell. I don't know where they are sitting. Right? So that is the reason we are telling that populations are never complete. We feel that they seem to be exhausted, but that list, it misses someone. It misses someone. That is the reason we say that populations are very hard to define and to observe. Now you understand this, the intensity of this point. Populations are hard to define and to observe. Now, on the other hand, if you go and see samples, if I say samples on other hand, they are easier to contact, and they are less time consuming, and they are less costly. Right? Time and resources are the main reasons why we draw samples compared to analyzing entire population. You understand? Even after doing a detailed analysis on the population, you will arrive, let us say, approximate results like those results on to which, when you compare to the samples, when you are doing analysis on the samples, then there is no meaning, right? You cannot go to a person to do an analysis. You cannot pull out complete blood of a person, right? You cannot do that. It is going to lead to a disaster, basically. So time and resources are main resources. Time is very important because you have to complete the project in a certain timelines. You have to do a study and complete it in a certain timelines, and you have to extend your results to the population. And resources, whatever the resources that you have that are working on that study, whatever the resource it can be time, or it can be the staff who is working on that, or people who are working on that, and whatever it is, are main reasons why we draw samples when compared to analyzing entire population. Correct or wrong?
Yeah.
Right? So now the question again starts over here. So okay, now we have entered New York University canteen at the lunch time and interviewed 50 people who were present over there for lunch. Is this the right sample for our analysis? Is this the right sample?
No, sir.
Okay. Why would you say that?
Because it could be any random people who just come there for lunch. Maybe they are not eligible for that.
Absolutely. Absolutely. So some tunes are there, some other guys are there who are only a part of supporting staff, right? If you go there and interview them, just they came there for lunch. And if you go there and interview them, are you going to understand what are the job prospects of New York University? No. Of course, they can say, okay, people are getting jobs. Right? So, whatever the sample that we are going to collect, it should be random and representative of the population. So, whenever you collect a sample from a population, you should be very careful in collecting a sample. Why you should be very careful? Because the analysis and the study that you are going to do on that particular sample and the results that you are going to arrive at, those results will be applied to the population also. They will be generalized or inferred. Inferred is the word that we use over here. Extend the results to the population also. Finally, we are interested in the population. Of course, we are not doing our study on population because it is difficult. That is the reason we are doing our analysis on sample, and we are finally extending or inferring those results to the population. So there is no meaning if your sample is not representing the population completely. So it should represent your population. That is the first and foremost condition of the sample, right? The first condition should be, it should be representative of the sample. If it is not representing the population, then you cannot consider that one as a sample. Don't consider that one as a sample. Now you are going to become a statistician, partially maybe, right? So you should have such wisdom, or you should have such a maturity to analyze yourselves whether it is a sample or what should I consider into population, or the sample that I'm considering is completely the correct or not. Right? The second condition for selecting the sample is its randomness. Each member of the sample should be selected randomly. Okay, if you don't select in the random manner, what happens? The same case happened in the example that we were discussing. You're going to the lunch hall and you're doing the survey in the lunch hall. That's what is going to happen. And you're going to get wrong results. And you're going to extend those results to the population. And finally, your decisions that you're going to take from the final conclusions or the results out of the study will be leading us in the wrong direction. Will be leading us in the wrong direction. Of course or not? Am I right or wrong? When you get the wrong results, and when you are taking decisions from the wrong results, what's going to happen? You're going to be led in the wrong direction. Am I right or wrong? How many of you agree with me? How many of you agree with me?
Yeah.
Everybody agrees or not?
Yes, sir.
Right. So that is the reason we need to get, even if you're not getting exact results or even I mean to say very accurate results, the results should be approximate. They should be closely representing the population parameters. Okay. So that was the reason I was telling you the sample that we were doing, that we collected over here in the lunch like New York University canteen. The random sample is neither, the sample that was there was neither random nor representative. So the random sample is collected when each member is chosen strictly by chance. He's chosen strictly by chance. We must ensure that each member is likely to be chosen. It should not be like a probability of a certain group of people are high. Choosing a particular group of people is high. It should not be like that. It should be something like probability of each member, and we should ensure that probability of choosing each member of the sample is equally likely to be chosen. So we violated both the conditions over there, right? People were not chosen by chance. They were a group of students, NYU students, who were there for lunch. Most members did not even get the chance or get chance to be chosen, as they were not on the campus at all, because the sample was not random. So what about the representativeness of the sample? A representative sample is a sample that accurately reflects members of entire population, represented a group of people, but definitely not all students. To be exact, it represented people who have lunch at New York University canteen. So now you must be wondering, right, how to draw the sample that is both random and representative in this solution, in this problem. If you were the head, and if you were the shoes in the if you were in the shoes of the head, what would have done? What would you have done? How you would have proceeded with this problem? Can anybody tell me how you would have solved this thing? Anybody? Nobody wants to answer, or how it is? I don't have any views, or okay. The safest way that is written over here, if you see here, the safest way would be to access the database, student database, and connect to each and every individuals in a random manner. That would have been the possible way, but of course it is not possible without assistance from the university, right? So final conclusions, what are the final conclusions? Populations are very hard to define and hard to observe, very expensive and very time consuming. That is the reason we, on the other hand, go with sampling. We do sampling and we do analysis on samples. So of course it would be difficult at first, but once you get experience, then you'll be very efficient in collecting samples and extending your results, right? And this becomes cheap and fast. And then statistics itself is a subject where you work with the incomplete data. It is meant for that. This is a subject which is meant for working with incomplete data. This never expects you that you should have complete data with you, right?